Hi everyone, I will start going through chapter 4 notes, which is starting to look at the regression line for bivariate data. If you need to grab your notes, please do so. Pause the video, you'll need to have these to make any notes. So looking at 4a, which is just introducing what the least squares regression line is. So you would have done a little bit of this last year in further maths, and you would have definitely done it in previous years as well. And possibly, if you're looking at data, you probably would have fitted a line of best fit to a scatter plot. So we'll have a look at all forms of fitting a line to a scatter plot. So just the process of fitting a straight line to bivariate data is called linear regression. So bivariate data meaning we've got, in this case, a scatter plot. So the whole reason we do this is potentially forecasting. So we want to fit a line to the data so potentially we can forecast for the future. This is done in so many businesses. It's done a lot in banking. It's done in lots of business models, things like that. If you can forecast and make predictions for the future, you're onto a winner. You can make lots of decisions moving forward. So that's our goal here. So where this name comes from, the least squares regression line, is, as I mentioned before, you may have done scatter plots in the past and you would have fit a line of best fit to that data. So you probably would have tried to put your line through so there's like an even amount of points either side. That was a really dismal attempt of that. That should have been a little bit higher. So you would have been fitting that by eye. There's actually a more accurate way of doing that rather than by eye, and it's called least squares. Now what it's actually doing is when it's fitting the line to the points, it's adjusting where the line is. So if I put a line in there, what it's doing is it's looking at the distance between each of the points to the actual regression line, and it's trying to minimize that. And what it's actually doing is the distance, each of these distances here are called residuals. And we're going to take a closer look at that further in chapter 4, but not in huge detail today. So the distance between each of the actual data points and the regression line fitted is called a residual. And the accuracy of the line is based on minimizing and you can see that it says least squares because it's actually minimizing the square of these numbers. So these all become squares. So squared is that distance of the residual squared. So it's your d squared. So we want the smallest amount of distance squared as possible. That's, in a nutshell, what your calculator is doing for you. So you actually don't even need to work that out because when you have the data, that is what your calculator is doing for you. All right, so on your notes there, it's going through this as well. So the least squares regression line is the line that minimizes the sum of the squares of the residuals. Now remember, the residual is just the distance between the line fitted or the least squares regression line and the actual data point, okay? When we are fitting a least squares regression line, we need to make it a few assumptions about the data that we're looking at though. And these are the same for when we're looking at the correlation coefficient. So the data must be numerical. We must have a linear relationship. We can't put a line on a relationship that isn't linear. So it must be linear and there's no clear outliers. Because remember, if you're got some sort of pattern that looks like this, and you got this little scallywag over here, that when you fit the line to that data, that's going to, that dot there will pull the line down. So the line actually won't fit the trend of the data. So no outliers. We can't fit a least squares regression line if we've got an outlier. Okay, so nice quick one today for a the process of fitting a line is called the least squares regression line. It's created by trying to minimize the sum of squares of the residual. Remember, the residual is the distance between each point and the actual regression line. And the assumptions are we've got numerical data, it's linear, and there are no clear outliers. All right, hope that's helped.